As we all know, the long-wall topochemical mining means for the silicon seams, we divided into the bottom core and the top core. We use the cutter machine to recover the bottom core, and we use the rear AFC to recover the top core. And the LTCC realized the leap from mining N layers to mining 1 layers. And the former Minister of Coal Industry once said, LTCC is a revolution technique for sickle seam mining. The first industrial test of LTCC in China was started in 1984, but the research of the LTCC began in 1982. And the 2 pioneers in this field is Professor Fan and Professor Wu. In 1984, the first LTCC panel failed because of the unreasonable shield structure. And in 1986, the shield was redesigned to the middle level drawing opening, which means the opening is in the middle of the cave-in shield. And the maximum monthly coal output is around 20,000 tons. After failing to achieve the expected results in nearly horizontal sickle seams, China started to develop LTCC in steeply inclined sickle seams. The thickness is around 20 meters to 50 meters, and 3 representative cases, including number 2 mine of Yaojie Mining Bureau, April 1986, and in November, the Meihe coal mine also used that with the thickness of the coal seam in the range of 25 meters to 38 meters, and the deep angle is over 45 degrees. And from 1990s, the high yield and high efficient LTCC in gently inclined sickle seams were developed fastly. 3 representative cases are Yangquan Mining Bureau. In 1996, number 1 mine in Yangquan Mining Bureau studied the low drawing opening LTCC, which removed the drawing opening from the middle to the lower. And the monthly output of the panel was 148,000 tons. And the second one is the Luan Mining Bureau. In 1993, all mines of Luan Bureau has adopted the LTCC technique. And the panel of Wangzhuang coal mine has the width of the panel has reached 270 meters. The annual output is larger than 4 million tons. And the Yanzhou Mining Bureau also started the LTCC in 1992. And for the Dongtan mines, the total year output is 4.5 million tons in 2001. The practice has proved LTCC is a highly efficient, low-carbon mining technique. Also, LTCC has some application in some complicated conditions. First condition is 3 soft mining coal seams. That is, the coal seam is soft and the floor and the roof strata is also soft. The coal seam F value is less than 1. First, the Zhengzhou Mining Bureau has started the 3 soft mining practice in 1988, and to 2000, the monthly output has reached 150 to 130,000 tons. Also, the Xuzhou and Tiefang Mining Bureau has tried the similar condition applications. Second condition is hard sickle seams with the F value larger than 3. And the representative condition is the Datong Bureau. In 1991 to 1992, the Xinzhou Yao and the Meiyu coal mine have used the high-level drawing and middle-level coal drawing. And from 1996 to 1998, the low drawing opening shield was used, and the fractal energy release model of coal blasting was established in order to improve the pre-blasting effect of the top coal. Also, in Jinchen Mining Bureau has also suffered the same condition, whose F value is around 2 to 4, and more attention was paid to the topical caving mechanism and topical recovery ratio improvement. Third condition is 3 soft and cold and gas outburst coal seams. In 1995, the Weijia mine of Jinyuan Bureau has tried the LTCC, whose average thickness is around 12 meters and the average deep angle is 20 degrees. And the gas content is 9.3 cubic meter per ton. And the LTCC was first used in coal and gas outburst coal seams in Weijia mines. And the second case is LTCC in Huaibei Mining Bureau. In 1998, the lightweight shield was used in Zhuxianzhuang coal mines, and in 2000, in 30 May 2003, the Lulin coal mine has occurred a gas explosion accident and resulted in 86 fatalities. So since 2004, some techniques such as drilling super deep boreholes in the floor and pre-mining top slice are adapted to prevent the gas outburst. This is the right picture is the top slicing mining method. And because of the significance of LTCC's successful experiments in the Jinyuan and Huaibei, the safety regulation of coal mine in China has revised due to our research result. Before 2022, there's a clause that writes prohibit the application of LTCC in outburst and coal seams. And in the 2022 edition of the regulation, this clause has been removed for the new regulation because of our excellent work. And the fourth condition is LTCC inclined and stably inclined coal seams. This is in the range of 6 seam. Deep angle is larger than 25 degrees. The first case is LTCC in Wulan mines of Ningxia. In 1992, Wulan mine carried out LTCC in number 3 coal seam with thickness of 6 meters, same deep angle in the range of 17 degrees to 37 degrees. Also, there are number 2 mines of Hebei Mining Bureau, Henan Province. The fifth is LTCC with a light shield, which means the shield weight is less than 8 tons. The lightweight shield has the advantage of low investment, and there are lots of coal mines that use these techniques. Based on the application of LTCC and larger mining height method, we also had some innovations. First, we combined these 2 methods together. In 2011, LTCC has used in the 20-meter thick coal seams with cutting height around 5 meters and caving height around 50 meters. Because the cutting height is 5 meters, it belongs to the large mining height categories in tons. And second case is 17 meter LTCC in Jinjitan mines of Shandong Energy Group. And this is in 2019, Shandong Energy Group developed 7 meter large mining cutting height in Jinjitan mine. And the average thickness of the coal seam is around 9.26 meters. So the cutting height is very high and the caving height is very small, so as to increase the overall recovery of the coal seams. Also, in steep inclined thick coal seams, the steep inclined coal seam refers to the same deep angle larger than 45 degrees. The first case is Weijia mine of Jinyuan Coal Bureau. And in 2003, the coal seam deep angle average is 43 degrees, and the average thickness is 50.5 meters. And also in Dayuan, in Shanxi province, we use LTCC with a deep angle of cosine is 53 on average and 62 at the maximum. LTCC was used in this condition, very successful. Besides, in order to measure the topical recovery in the underground mines, because we need to know how much we have mined and how much we didn't take it, Professor Wang have invented the topical migration tracking mark and observation method of topical recovery. And this is the mark and its receiver. And we have used this method to measure the recovery ratio of different coal mines, more than 10 mines in China. And the observation result showed that at the both ends of the phase, the working phase, the topical recovery is relatively low. So we also doing something about the redesigned the structure of the shield spot, and we also used it in the application. Intelligent mining is being a very large advance, and the main three issues is automatic identification of the coal and rock, intelligent mining process, and intelligent drawing of top coal. And we also did something in these aspects. I will report it later. Besides, because we have doing lots of the application in China and very successful, so we also had some export. In November 2004, Yanzhou mining set of LTC equipment provided by Yanco was put into All-Star underground mines in Hunter Valley region of New South Wales. And in October 2030, Yanco provided a set of two-leg caving shield to another mine in Queensland. And also in July 2022, the complete set of LTCC equipment was also exported to Turkey. Okay, the fourth part is the main achievement of LTCC Center. The LTCC Center refers to the Topical Caving Mining Technology Center, which is established by the Minister of Coal Industry in Beijing, CMT, and it was started in 1994, and this is the inscription of former Vice Premier Jia Huazhou, and also the documents that when it established the Professor Wang. And in 2015, it has renamed as the Coal Industry Engineering Research Center of Topical Caving Mining by China National Association, Coal Association. Since 1994, we have received 6 national awards, including 1 first class and 5 second class. Also, we have lots of national invention patents, and we published some books and papers. The center organized multiple domestic and international academic conference. In last July, we organized the International Conference on Green Intelligence in mining for coal seam, and we have 55 presentations in total, including 38 domestic presentations and 17 overseas presentations. And this is the pictures of the conference. I believe some of the audience maybe all the picture. Besides, the research center are trying to introduce China's coal seam mining and LTCC technology to the overseas. Since 2011, we have attended ICGCM, US Rock, Rock, World Mining Congress, etc. And in 2014, ICGCM was first introduced into China by Professor Wang, and it has been held for 9 sessions in China. And in 2017, Professor Wang also was awarded by as a Side Pen Award, which is 1 person per year in the whole global. Also, we have some national scientific and technology awards related to LTCC. We have a very important influence in the topical caving research field. With the keyword of topical caving, we can find more than 1,000 papers in the Web of Science and Engineering Village. And from 1982 to 2022, half of the top 10 authors are the members of the center. And both the SCI and the EI database, the first place is Professor Wang. We have a long history of research on the fundamental theories of LTCC, and BBI research drawing theory proposed by Professor Wang also has been written into the American textbook, the third edition of longwall mining, and which is used in 8 universities in the United States and Australia. Based on our theory research, we also conducted and completed lots of engineering projects, including different conditions and some very complicated conditions. And in our recent research has made some image-based intelligent control of co-drawing. This is the problem that as we all know, if we want to realize the intelligence of the LTCC, we must face the problem of the control of co-drawing. There are 3 main problems. First is how to accurately identify the co or the real AFC. And the second one is how to calculate the rock mix ratio or the real AFC in real time. And third one is how to realize accurate control of co-drawing on-site in the underground. As we all know, the technical route of visual co-recognition has lots of the paths. For example, the X-ray or gamma ray, visible vibration, sound signal, etc. But we have focused on the image-based control of the co-drawing since 2008. And Professor Wang has got the first innovation patent in this field in 2008. And this is the overall working path of this technology. First, we need to have the image collection and processor, and with proper algorithm and recognition software, and finally we can control the shield. So step 1 is we need to establish the database of core and gauge images with different illuminates, and a dust removal algorithm has of image based on the spectral analysis is proposed. And then by comparing the grayscale texture features between core and gauge, a method for extracting the maximum difference features in the image established by introducing the normalized characteristic difference index, so that we can distinguish the core and gauge better. And then a fast multi-scale intelligent model for co-gauge boundary detection is proposed, which solves the problem of mission detection of small co-gauge targets and force detection of weak boundary in the traditional model. This model eliminates the cavity of the staked bodies and adhesion of the co-gauge and missing detection of the target. The recognition accuracy is over 98%, which is very high. And voxel-based reconstruction technique of co-gauge block shape is proposed, which is used for the fast calculation of the co-gauge volume and the rock mix ratio. And the relationship between the co-gauge surface area and the stacked body volume is needs to be figured out first, because the camera can only get the surface picture of the core and gauge. We need to have the function find the function between the surface area and the real volume, so that we can have a more accurate control. And then by using the physical simulation, field measurement, and numerical simulation, the relationship between the topical recovery ratio and the rock mix ratio was established. This is the laboratory experimental results. And also this is the numerical results. And with different results, we can see if we control the rock mix ratio in a special or a certain range, we can have a more higher topical recovery. This is very important. For example, if we have the rock mix ratio at 11%, then the topical recovery can have a better percentage. Also, a new generation of topical migration tracking mark is developed to record the drawing time and help to optimize the drawing process and drawing parameters in the practice. An accurate multi-round co-drawing technique with controllable equipment movement at the topical boundary was also developed because we think that if we can make the topical boundary move slowly and with multi-rounds, the topical recovery will be higher. And this is what we designed and was manufactured for the dust-proof image acquisition system with pneumatic sealing cover, dust sweeper, and high-pressure dust blower. And the image acquisition time interval is less than 5